This again, I'm saying it again first. I have to drink coffee first. Okay. My gosh. Now we're done with the concept of chemical equilibrium. We'll go back to chemical equilibrium problems. Okay, so I told you while I was in theory, right? I have to remember the ICE. Now I have to make my own problem in order for us to understand. Okay? I will not pattern to examples in the books. I have to make my own problem. Make my own problem. My gosh. Di ba? Para masabtan. Okay? Like that. Okay guys? Klaro ba yung ano? Whiteboard? Ah, okay. Wow. Say for example, mga palangga. Nakakalata. Okay. Say for example, ammonia. Okay, ammonia. Let's say, I will make my own problem. Okay. Okay. What's this? 4 moles of ammonia, for example, on the 4 moles of ammonia, okay, in, for example, in a 4-liter container, right? In a 4-liter container, okay, decomposes. I think it's no problem, guys. Decomposes into, let's say, not let's say, this is really nitrogen gas and hydrogen gas, right? Okay, like that. Okay, and then foremost of ammonia, not ammonium, okay, ammonia in a 4-liter container decomposes to nitrogen and hydrogen gas. And then, ganun siya. So what will be, oh my gosh, wait, what will be the equilibrium constant of the expression? What is the equilibrium constant expression? Okay, ganan. So calculate, okay, calculate the, okay, the equilibrium constant. Ganan. Okay, get the point, mga kalangga? Okay. So we need to apply, we need to apply the ICE technique, right? And then we need to show the equation first. Okay, ammonia gas is equal to nitrogen gas plus H2 gas, and then balance the equation. It's gonna be 2, 6, 3, or 6 hydrogen and 2 N2. Perfect. This is our balanced chemical equation. Ganon. Okay, now ICE. Meaning initial, okay, at the concentration when they produce the product, and then at equilibrium. Okay, get the point? Something like that. Okay, so initially we are referring here for the concentrations because it's chemical equilibrium. Concentration is mole per liter. Okay, mole per liter. And in this technique, we have the reactant ammonia. Concentration initial of ammonia in your 4 moles divided by 4, right? Correct? Yes, correct mga palangga. So 4 divided by 4, so that is 1. Right? 1 moles per liter, ganun na chuba-chuchu, or 1 molar. Ganun siya, di ba? Okay. Initial, 1 molar. Understood that the unit of these concentrations are all molar, huh? Okay? You need to put individual molar, something like that. Okay? And then here, initially, we don't have M2, 0. We don't have also hydrogen gas, we don't have hydrogen gas, also 0. Okay? And there are concentrations produced in the product. So we have here, okay. So we have the concentration produced in the products. Let's assume the X moles for the concentration that we produce in the reaction, right? We don't know yet, right? Of course. Ganon. So it's going to be plus because, as I told you earlier in the theory, the concentration of the product will increase. Okay, because the reactant will give the concentration to the product. So by common sense, it will increase. So let's have X here. X. That is the molarity, right? Molarity X. Okay. Now, in the hydrogen gas, we have three coefficients. It's gonna be 3 times X because the X is our unknown. Ganon. Okay, so 3 times X like that. And what will be happening to the ammonia in this case? So it's gonna be 2 times X. Ganon. But since it gives to the product, it is negative 2x. Again guys, algebra pa rin siya, math. Okay? Minus 2x. Even though this is already a chemical problem on chemistry, we still employ math algebra to understand properly what's happening in our chemical reaction. Okay? Ganon. So our equilibrium, this will be now equal, meaning to say the rate of the forward reaction will be equal to the rate of the reverse reaction, or the concentration of the reactant is equal to the concentration of the product. Okay, like that. So for example, we did this in equilibrium, right? Ganon. So it's gonna be, we have the initial here now, well, at 1. So it will become now 1, okay, 1 plus minus 2x. Okay, because it's just the same. 1 is equals to 2x in equilibrium. Okay, so this will equal 1 minus 2x. Okay? You get the point? Okay? Actually, it is 1, okay, 1 plus minus 2x. Okay? Is equals to 0. Therefore, that's it. 1 minus 2x. Ganon. Parihara naman na siya, guys, no? Diba? So this is 1 plus minus 2x. Now, in the nitrogen gas, it will become 0 plus x. That is x only. Because that is 0, not 1. Okay? If this is 1, this is 1 plus x. But this is not 1. This is 0. And the same also here, this is 0. So this is 3x. Or 0 plus 3x. To be precise, I will say, for the purpose of understanding, 0 plus x. And then 0 plus 3x. So this is the part where the students cannot understand very well. Because some instructors will go directly as x. They don't know that the 0 plus x is just equals to x. And then what if there's an initial concentration of N2 and H2? So the students will be confused now. Okay? But based on what I discussed is based on my weakness when I was in college. And then I keep on researching, why like this? And I understand by myself. Okay? Okay, not, because I cannot get it quickly also, that fast. That's why. Okay, so 0 plus x and 0 plus x. That's why the teacher will say, it's just equals to x. Or it's just equals to 3x. Because you plus the 0. But if there is an initial concentration of N2 and H2, for example, it will become 1 plus x, 1 plus 3x, or 2 plus x, 2 plus 3x. It depends on the situation. I'll just emphasize y. Okay, so x, 3x. Okay, that's why here 1 plus minus 2x, and after an equilibrium, it will become 1 minus 2x. It will be subtracted because the concentration of the reactant ammonia will be reduced during the chemical reaction. It will give to nitrogen gas and hydrogen gas by common sense. Okay, now we are focusing on the equilibrium part because our topic is chemical equilibrium. You get the point? And now, calculate the equilibrium constant. O ganon. Di ba nakakaloka? Now, this is also a tricky part. Okay, now, we have the chemical equilibrium constant, right? So, chemical equilibrium constant is equals to the concentration of nitrogen gas. We don't have coefficient, 0. It's just, so, as is lang siya, no exponent. Okay, because the coefficient will become exponent. And then H2 have 3 in the coefficient, or most it will be raised to the power 3. So H2 raised to the power 3. And then we have ammonia denominator concentration raised to the power 2. Because ammonia has coefficient 2 raised to the power 2. Now substitute na in terms of equilibrium. This in third. E. Ice initial concentration and equilibrium. Okay? So we always think of ice in doing this type of problem solving in chemical equilibrium topic of general chemistry lecture 2. Now we are trying to solve the chemical equilibrium constant expression. Now we enter here in the equilibrium, pila siya. M2 is just X. Okay, X o X. Ganon. Okay, like that. You get the point? Okay, ganon. H2 o 3x here. So raised to the power 3. Ganon. Ammonia 1 minus 2x lang siya raised to the power 2. Ganon. So you cannot compute the equilibrium constant if you know the concentration of the reactant and the product. But still you don't know, right? Now, what is your concentration initially? Moments you can pass 1 minus 2x o takabaw. You get the point? So what takabaw ang higayon na? So how can we do that? Then we have the liters of ammonia, nitrogen gas. Pahiburo ba na siya, guys? Okay? Get the point? This ammonia, nitrogen, and hydrogen are inside the container, the same container. Get the point? That is 4 liters. Get the point? So that is 4 liters container. So 4 liters. Get the point? So mole per liters. So ganon. So how can you solve for X? Because we need X as a concentration man siya. Okay? So, concentration siya. Sama naman na siya pagpuan. So, concentration is equals to 3x. Ganon. And concentration is equals to moles per liter. O, ganon. Ganon. And then, we don't know yet. But this is the 3. So, we need to have the value of either one of the nitrogen and one of the value of the hydrogen. So, get the point. Now, in this kind of problem, we don't have the X, the concentration of the product here. Okay? But this concentration is initial lang siya sa ammonia. We don't know yet the concentration of ammonia in equilibrium. We don't know the concentration of nitrogen in equilibrium. And we don't know the concentration of nitrogen in equilibrium. Okay? That's very clear. So we cannot compute for the equilibrium constant. Now, as I told you, this is only a fabrication question for myself. Okay? It could have been that there is an equilibrium concentration given either nitrogen, hydrogen, and ammonia to solve the equilibrium constant. Or else, equilibrium constant will be given in the problem. Okay? Because I create my own question by my brain cells. Okay? I did not pattern to the examples of the books in YouTube or in Wikipedia or any reference. I made my own so that I can understand very well. I can discuss very well to you guys. So it could have been there's a value of equilibrium constant in your problem, okay? Or there is at least concentration at equilibrium of hydrogen gas, nitrogen gas, and ammonia gas so that you can solve for the value of the equilibrium constant. Right? Ganon. Okay, so let's say lang na actually equilibrium constant sa problem na 4 times 10 to the negative 3. O, ganon. Substitute this 4 times 10 to the negative 3 here. So, 4 times 10 to the negative 3. And then, all of them are having x, right? As one unknown only. So, 3x plus 3 times 3x times 3x is 12. 3 times 3 times 3, 27x cubed, right? 27x cubed, times x equals 27x to the 5, because it's multiplication, okay? And then, the bottom part also 1 minus 2x, this is a polynomial, right? So 1 minus 2x times 1 minus 2x, and then solve for the value of x. And then you play around cancellation of, chuba chucho. Then you can simplify further for this, and you can solve for the value of x. And that is our concentration at equilibrium of this type of reaction. Oh my gosh! Okay? Ganon! Wala akong kabush. Wow! So crispy. Nakakaloka. Na-crispy na akong kuhaan, kabush. Napait naman. Naman ibang pait. Nako. Ay, kapit na siya pala. Pait na kiligay. Hindi wala siya na entire pait. Char! Okay, sige, yaw-yaw. Wala na siya may tabo, guys. Okay? Ano lang siya. Okay? Namukuha kag pattern din sa book, letter ha, ikabalik na ako para ma-perfect din na makasolve yun ka. Because that's only my, what do you call this one? An introductory fabricating problem. Okay, so that's it. Okay, thank you so much. You can share and like this video, and you can subscribe to my channel if you want. And you can also click the notification bell for some newest updates of my signature voice. Ay nako! Bye-bye! God bless everybody! Oh, ganon.